So I was trying to explain inferential, inferential statistics. So inferential statistics basically involves testing hypothesis. You test an hypothesis to arrive at an inference. Basically, you test an hypothesis to come at an inference. For example, a statement that has not been tested to either be true or false is an hypothesis. Now, when an hypothesis is made, then you can go on to carry out a test to test whether the hypothesis is right or wrong. Now, in inferential analysis, we call it inferential because by the time we test our hypothesis, we come to a conclusion that is called inference, and that inference is used to infer on a population. For example, let's say I say something like people between the age of 25 and above in Bielsa are, let's say graduates, let's say they are graduates, people from 25 and above in Bielsa are graduates. Now, that is an hypothesis it is a statement that has not been tested. Of course, to test that kind of statement, we have to do a research. Now, that research is going to involve collecting data, and that means you have to look for people that are actually 25 and above to collect data from them. Are you finished school? Yes or no? Basically. Now, it will be impossible to get everybody in Bielsa that is 25 and above. So, what do? We do what we call sampling. Sampling is taking a subset of a population. We have a sample, we have a population. Everybody in Bielsa that is 25 and above is a population. That's the entire population. For example, they say the population of Nigeria is 120 million. So that's our population. So now, I don't know the number of people above 25 in Bielsa, but whatever the number is, let's say 2 million, maybe let's say 500,000. That's the population. So, of course, I can't go to 500,000 people and start collecting data from all of them. I have resources constraints basically, so it is not possible. What do? I sample that population. I take a subset of that population out. Let's say out of 5,000 youths that are above 25. Sorry. Let's out of 5,000 youths that are above 25, I take out 500. Let's say I don't really have money to do a big research. I take out 500 people and I ask them the question. So by the time I ask them that question, I do my analysis. Whatever I get from the analysis, we call it an inference. Let's say by the time I carried out my analysis, most of them are not actually graduates. So I can infer that youths in Bayelsa State above 25, most of them are not graduates. I only sampled 500 people, right? But I'm inferring on the entire population. So I can infer on an entire population just by working on my sample, basically. So, what are some methods of of an inferential analysis? So, we have different types of inferential tests or inferential analysis. We have the correlation. We have the regression. We have chi-square. We have the t-test. We have a whole lot of them, but the most common one is regression, of course. Then correlation, regression and correlation t-test chi-square is probably common too. So I will just explain what those two basically mean. So I have explained what an hypothesis testing is already. I've explained what an hypothesis test is. So if we are talking about correlation, correlation shows relationship between two variables. What are variables? Variables are data. That's just it. Variables are data. If I collect data on age and marital status, of course, you are going to have a column. So the heading of that column is going to be age, right? And the heading of another column that has another data point is going to be um, age and marital status. So the heading is going to be marital status. So now the data now, which is going to be in rows, those are the data in rows. But I named the entire data for a column. I named it with a variable name, and that variable name is an age. So a variable basically contains data or stores data. And get this, because this is very important. It is important in the sense that we need to apply this. This class is scheduled for, is it 2 months or so, and it's an end-to-end class, as you said. So obviously, I think I promised that we're going to do Python. I think I promised we're going to do Python. So if I'm going to eventually do Python, what I'm saying right now is very important. A variable stores the data. Like I store my data in a variable. If I say age is equals to 25, the data I collected is age, is the 25, right? Is the 25. But then is the name of the column on which that 25 is under is what is age. So the age is the variable name that is storing the data point 25. Do you understand that? Listen,
Yes, yes,
do you get what I just said?
yes.
Can you try and explain it back to me?
Okay. You said a variable basically contains and stores data, and you cited an example that if age is 25, so age is the variable, while 25 is the data.
Okay. So the variable now, it stores in the data basically. I think you've got some explanation. So now, so that means if I'm talking now and I say something like the variable, you should know what I'm trying to say. It's just jargon that is used in data analysis work when I say variable. Of course, if I say the variables that affect the enrollment rate into a school now, the variables that can affect the enrollment of a child into a school can be a lot. The family can be a variable that is affecting that decision. The source of income of the family can be a variable. The the child willingness itself can be a variable. So resources can be a variable. Availability of schools in the environment can be a variable. So that means to come to a particular decision point, there are different factors that are always in play, and those factors we call them variables. Now, the correlation shows relationship between variables, or shows a kind of association between two variables. It shows association between two variables. That is, I can check if this thing and this thing, if they are connected together. I can check if this and this are connected together. That is, I can basically check if the family size is having an effect on the rate of enrollment in schools. So we can ask a question that, is there a relationship? Is there a relationship between these two variables? So we can basically ask that kind of relationship. The type of correlation, a correlation can be positive correlation, it can be negative, and it can be no correlation. Correlation basically ranges the if we calculate if we um, use correlation as a metric in our analysis and we're trying to check for a correlation between two variables or more or two or more variables. What we get, the results we get, we call it a correlation coefficient. Correlation coefficient denoted by small letter r, small letter r. So now, That correlation coefficient, the value is always between 0 and 1. Between the 0 and 1. Now, if you calculate correlation between two variables and you are getting a negative value, for example, I calculate my correlation and I'm getting minus 0.5, 1 minus 0.67. It shows a negative correlation between the two. That is, one is affecting the other negatively. That is, if there is an increase in one side, there is a decrease in the other side. If there's an increase in one side, there is a decrease in the other side. That's basically what it's saying. It's saying the two are not compatible. So an increase in one side or one side being good, it causes an adverse effect on the other. So if one side is doing good, the other is going to do badly. So that is a negative correlation. A positive correlation is that, oh, these two, they maybe help each other or augment one another. If I calculate my correlation, I'm having, so a correlation can be weak correlation, it can be moderate correlation, and it can be high. So two things can be highly correlated. They can be mildly correlated and they can be weakly correlated. If my correlation answer is between 0 to, let's say, 0.3, 0.35, that is it is a weakly correlated. Those two variables are weakly correlated. On the other hand, if it is from, let's say, 0.45 to like something like 0.6, they are let's say they are moderately correlated with one another. It's not weak. The correlation is not weak, but then it's not that strong either. But then if it is from, let's say, 0.65 to 0.9 something, that means those two variables are highly correlated. One affects the other most definitely, or one is as a result of the other. That's just what it's telling us. Now, the limitation for correlation is that correlation does not um, give us, tell us basically, it doesn't tell us the cause and effect. It shows relationship, right? But it doesn't tell us the cause and effect. What do I mean by that? It doesn't tell us whether it is this one that is affecting this one, or this one that is affecting this one, or the rate of change of one in response to another. It only tells us that there is a relationship between these two. What's causing the relationship? We don't know. What is the rate of change in one variable to another? We don't know. So it only tells us yes, there's a relationship or there is no relationship. Now, to now probe further, now, to know which is actually affecting which, and by how much, or by how much is this affecting this. So we can probe further now to ask that question, like, which one is actually affecting which one, and by how much is it actually affecting the other. So now that is where regression comes into play. That is where regression comes into play. So um regression tells us what is causing the change and how one of the variable is affecting another variable. That is, let's say, and it follows what we call a regression line of regression. A regression line of regression. A regression line of regression is basically a straight line equation. I'm trying to see where it's represented in. Okay, this is it. I'm sure we've seen this before. It's a straight line of regression. It's a straight line equation. Let me try and use it to explain what regression is. In this equation of a straight line that's on the screen here, this highlighted one, this y equals to a plus bx plus e, right, is a straight line equation. In this equation now, we have two variables. We have two variables, the variable y and the variable x. Now these two variables, of course, they store data. They basically represent some data that we collected. Now the other part is this variable x that you are seeing now. There is something at the front. What do we call this? This b in mathematical term. What is that we call it? It is in front of the variable. Anybody know that? Does anybody know that? What that b is called? Yeah, that one. People should answer me now.
Okay, I think maybe coefficient of x.
Yeah, thank you. It's
Maybe
called the
answer that.
coefficient of x. Is the coefficient of x. So is at the front, is in front of x. So we call it the coefficient of x. Basically, is the coefficient of x. So this coefficient now, it is showing how much this variable x is contributing. Now, another question I want to ask in this, I know I said y is a variable and x is a variable. Basically, one of these variables is dependent on another. That is, we have a dependent variable and we have an independent variable. So I'm going to ask again, which one is dependent and which one is independent? Oh, yeah,
Okay, I think x is dependent and y is dependent.
x is dependent.
No, no, no. X is independent. Maybe. I'm not really sure.
For me, alpha.
Alright, so sorry, so sorry. Okay, please can you share your screen again? The dependent, the way we are showing. O- Okay, so the question is which one is dependent on which one?
Yeah, which one is dependent and which one is independent?
Between what and what? Sorry.
I said that equation of a straight line has two variables,
Okay.
variable y and variable x, and one variable is dependent
Okay.
on the other. So which one is dependent and which one is independent?
Y is independent and
Y
X
is
is
what?
dependent. Y is independent.
And x is what?
In
X is
X is
dependent
dependent.
on y.
Y is independent.
Okay. I think yeah. I think what Messi said is the correct one. The x is the independent and the y is the dependent. So it is the y that is depending on the x. That is the value of x now, whether it goes up or whether it comes down, it is going to have an effect on y. So that is, if there is an increase in x, there is going to surely be an increase in y. Why is that? Because y is equals to a plus bx. Now the b is the coefficient and the a is a constant. I think that's the intercept. The intercept on the y-axis is a constant. So let's say we have a kind of an equation now. The if x goes up, y is going to go up, and if x comes down, y is going to come down. Let us use an hypothetical data now. That is, try and confirm what I just said. So let's say y is let's say admission rate. Then we have a constant. We would have, before you have this kind of equation, you would have run your analysis on a data from the past, because it's a regression line of regression, and as I said, we use it to forecast, use it to predict the future. So before you get to a regression line of regression in the first place, you would have done an analysis on your historical data. So when you do an analysis on an historical data, you get your regression line of regression, which is going to have the intercepts, the coefficients. The coefficient is basically going to be in front of your variable x, and then the e is just for error, your margin of error. So now, if we have we've done an analysis on an historical data, and then we now have y equals to, let's say the intercept a is 2. So we have y equals to, let me type it on the screen so it makes more sense. So we have y is equals to, let's say a now is 2, then the coefficient of x is 3. Let's remove my error. So we have this equation now. So now imagine if I want to forecast. Now in this case, y is our target. We call it target variable. A variable can have different elements. It's called target and it's also dependent. It's our target variable. That is what we want to predict. It's basically what means what we want to predict. So it's our target variable. This is what we want to predict. And now the x is our feature. We call it our feature variable. That is, it is what helps us in predicting y. So it helps us in predicting the y. So let's say, for example, now our x is to be e.g. Let's say x is equals to okay, let's say x is a list of data. That is, x is 0, x is 0 at some point, x is 1 at some point, and x is 2 at some point. If we input these values one by one and we substitute x with each of these values one by one, what is going to be the corresponding value of y at every instance? For first instance now, if we substitute 0 for x, what's going to be the value of y in the first instance? Oh yeah, oh yeah.
Mm.
Did you get what I said?
Yes.
And what would be the value of y at first instance if we substitute for x equals to 0?
Two.
Eh?
Two.
2. Are you saying 2? Are you eating?
I said two. I'm not eating.
The 2 was sound as if you were trying to swallow something. Okay. Let's say you agree now, it's 2 now. Abi? Answer now.
I think zero.
0.
Mm.
So we have two answers now. One answer is 2, another answer is 0. So if we put, if we equate the value of x in this equation now to be 0 in the first instance, y is going to be 2
Okay.
actually, because 3 times 0 is going to be 0, right? And 0 plus 2
Yes.
is going to
I
be
didn't
2.
check. I didn't use that equation. That was why. So sorry.
Okay, it's okay. So now that means at the first instance, the value of y is going to be 2. Then at the second instance, if we put x to be 1 here, what's going to be the corresponding value of y?
5.
5. So that
Yes.
means, an increase in the value of y is affecting, sorry, an increase in the value of x is affecting y, showing that it is actually the y that is depending on the x and not the other way around. If you like, if you put the value of y to be equal to 1 million, it is not having any effect on x. So basically, that's the concept of regression, and that's how we use it in forecasting. If you carry out a regression equation, your aim is to get a regression line of equation that can be used to forecast future data. And this is basically what we call a model. that is a model. If they are saying model, this is a model. Just if you do and you just build a model that's going to predict this value of y, that is a model. That's basically what it is. It gets complex now. This is a simple model, anyways. It gets complex when you have um, more than one variable that is acting as a predictor, that is acting as a feature rather. So if you have like seven variables now that is predicting the target variable, that means we are going to have like x1, x2, x3, x4, x5, x6, x7. And each of these x's, they are going to carry a coefficient, and the value of that coefficient is going to be indicating whether they are contributing positively to the value of y or whether they are contributing negatively to the value of y. So that is if the coefficient now is minus, if the coefficient in front of x is like minus 3 and not plus 3 in this case now, that means x is contributing negatively to y, because by the time we put minus 3 times, let's say 1, and that's minus 3 times 1 is minus 3, 2 minus 3, that's minus 1, so that is a negative effect on y. So the coefficient of the feature variables now, it shows how a variable is contributing to the dependent variable, whether positively or negatively. And that's the basic concept behind regression. So we've explained correlation, we've explained regression.